Okay, question 6. Part A is to draw our force diagram. So string here means we've got tension, weight of the rod acting at its midpoint because it's uniform, 0.8 g. Peg at C, so we've got that normal reaction. Now this is a rough peg, which is a bit weird for one of these questions, but as you'll see it doesn't really come into it at all. But it means there will be friction, which we'll call mu times RC. That's part A done. So part B is to find the tension in the string. So you might be tempted, like we've done for all the rest, to start with up equals down or left equals right, but the problem with that is the reaction at C and the frictional force both act up, and they also both act left or right, so you're going to get lots of variables and none of it's going to cancel out. So the best way to do this one, which is different to the others, is to just start by taking moments about C. And the reason to do that is the line of action for the normal reaction and the friction go through C, so we can ignore them. This force we know, and this one's the one we want to work out. We don't know any angles at this point, but as you'll see, everything's going to cancel out. So moments about C, we've got 0.8 g, which is the weight, multiplied by, now the distance from C perpendicular to the weight, which is this distance here. Well, along the plank, that's 2a. If I call this theta, then it's 2a cos theta. And in the same way, we've got tension, and then the distance from C perpendicular to the line of action of the tension is going to be all the way along here. That's going to be 7a times cos theta. And you see that we can actually just divide both sides by a cos theta to get that tension is 0.8 g times 2 divided by 7. 2.24 newtons, or let's say, well, in this case we can just write it all down. Right, for part C then, we're now told that theta is 20 degrees, and we need to find the magnitude of the normal reaction at C. Okay, so again, the best way to do this, because we don't care about the frictional force, is just to go straight for moments, but this time to take moments about A. The benefit of taking moments about A is that the tension's line of action goes through A, so we can ignore it, but also the frictional force's line of action goes through A, so we can ignore that as well. So taking moments about A is going to make this quite nice and straightforward. So we've got 0.8 g, the weight, multiplied by, now it's 5a cos 20, and that's going to equal the reaction at C time, now this is a nice one because here from A, the force RC acts perpendicular to the plank, so we just need the distance along the plank, which is 7a. And that's it. So dividing both sides by A, we can see that RC is equal to 0.8 g times 5 cos 20 divided by 7, which is 5.3 to two significant figures. And we're done.